connecting. Okay. Thank you very much for joining. As I said, thank you very much to Lee Howard and John Brzezowski and Zaid for preparing the materials for this workshop. I really appreciate it. And with that, Lee, if you would like to get started, that would be great.
So I'm not going to bother introducing myself. If you don't know me, then it's not important who I am anyway. We're talking today about IPv6 only, not just IPv6. Hopefully everybody's tired to death of hearing about IPv6. But I'm not going to assume that everybody is keeping up with everything that's going on, how far IPv6 is. So I included some charts in this slide deck, mostly so that people would have the references to know what data exists where, and where you can find it for future reference. Some of these are a month old, and things, of course, have continued incrementing. This is the chart most people see most often about IPv6 deployment, up and to the right, unsurprising. But this is worldwide, so how much data does Google sees about 19% of its connections to it using IPv6 worldwide, which is, I think, is still pretty significant. But what I did want to point out here is sort of this bushy line effect. What happens is there's not a diurnal sort of network effect, a usage effect, but it's actually weekdays and weekends. So the top of the line, it tends to be the weekends when people are at home, and the bottom of the line tends to be weekdays when people are accessing Google from work. Meaning, the implication is that mobile providers and residential ISPs have done significant IPv6 deployment, but enterprises have not, and enterprises are lagging significantly. I'm going to come back to that. That's sort of the impression that we get, the information that we get from this. So Google also includes per country adoption. It's wonderful to see that there's so much adoption. The yellow, the orange, reddish ones are places where there's significant adoption, but IPv6 is a little bit slower than IPv4. And if you hover over them on that map, you can see by how much. ISOC does report monthly stats combining data from, I think it's 5 or 6 different measurement folks now. People we've heard of, Akamai, LinkedIn, Facebook, and aggregates that data to show which ISPs worldwide have done the most IPv6 deployment. And there's, John Brzezowski right up top, Comcast, great job. Even though it says 54%, I'm sure he will tell you that they are way beyond 54% deployment. That's just what the aggregate of those networks are seeing in terms of connections from them. This is Eric Vinke's site. He does a status on how many of the top 50, the Alexa 50 sites for any given country are IPv6 enabled. He's got them weighted using a metric that's basically correlated to how much DNS. So the #1 Alexa website is more important than the number 50, but then he also just has a straight percentage. And then what percent by country? And there's a lot of countries now. And actually most of these have gone up at least 1% in the last month. So there's a lot of countries with 20, 30% or more deployment. So in case you didn't know where we are and how we've gotten here on IPv6, the deployment is still pretty significant, 30% or higher in some countries. Here we've got, again, Eric Vinke offers a projection tool on his site. So you can take the Google stats, which is the ones I'm using here, and do sort of a typical adoption curve is going to be an S-curve. So we've got, just using historical data, at what point would you expect 50% of traffic of hits on Google worldwide to be over IPv6? And it's about middle of 2019. That's 2 years away. It's half of the world is going to be using IPv6. That's why we're starting to move beyond just how do we get IPv6. Here's APNIC does some measurements. Here's sort of their summary by region. Again, there's the only place where it's tiny is Africa, and there's some good news coming out of Africa. The other thing that APNIC does is they show you on that page, this is just the United States, they'll show you which networks have how much IPv6 available. So I've sorted this list by percent IPv6 capable. And when Facebook, when they see that 99.81% of hits from Facebook are coming over IPv6, that's essentially IPv6 only, right? I mean, there's essentially, if 0.09% or 0.19% of your traffic is IPv4, IPv4 is, it's a second thought. You're into the long tail of transition at this point. And I included, the top 20 or so just to show how many networks are essentially IPv6 only. And these are not just Facebook and Google and Verizon Wireless, but also lots of universities and several different kinds of carriers there. So this is, again, at this point, and you can sort of argue where we define it. At this point, we're looking at IPv6 only as far as we can tell. The one that's weird there's a couple that are weird. The second one there is Midwest Internet, where 99% of their customers are v6 capable, but only 0.4% are actually using it when it's available. That's got probably a measurement anomaly, but I haven't actually poked Jeff Houston to ask about that if he has a guess about it. So this one was distinctly, Fred pointed that to me, or maybe I learned it from his article. Hurricane Electric in their v6 adoption reports include the metric showing how many ASNs are v6 only and v4 only. This again has gone up in the past month. I checked it this morning. I think it was 345 or 346. 345 ASNs are only announcing v6 prefixes, which is, okay, it's 0.5%. I have not done an analysis on all of them because it's sort of hard to correlate by name and go back and forth and see what else might exist. Most of them look like research networks that do have a corresponding v4 announcing ASN, but not all of them from what I could see, or I couldn't find the correlating v4 ASN. The fact that there are networks, so now if you're only announcing v6 prefixes, that's going to be arguably, potentially, a v6 only network, right? It might be a completely standalone separate network, which is now, as routing working group chairs in particular, we need to be thinking about how am I routing v6 without any v4 support. I know we've been thinking about that for a while. That's sort of what I wanted to emphasize here. Apple also had a slide showing a rise in the number of IPv6 only hosts. There are lots of companies that have been talked about their transition to v6 only. I've just listed some here: Microsoft, Cisco, Deutsche Telekom, T-Mobile. I'm sure Zaid's going to talk about LinkedIn. But yeah, that's right. Those are Facebook. And so the
question, please.
What's that?
A question, please. So I see a lot of IPv6 networks, right? IPv6 only networks. Mm-hmm. But do these guys do also the network management with IPv6, or they're still using a loopback with IPv4 for SNMP, Netcom, Syslog, IPfix, you name it?
I have a feeling that John is going to give a very concrete answer to that. But from conversations I've had, yes, by and large, they are moving towards a v6 only management network as well.
Okay, thank you.
Now that's not exclusively so, but for that those 300 and some, my expectation is if they aren't there already, that's the direction they're moving.
Well, I have to step away. I can throw in that for Deutsche Telekom, we're working on v6 only management. It's the new network, TerraStream.
So, sorry, I had to step away. Maybe you covered it, but why is it only faster 1/5 of the time? That means that 80% of the time V4 is faster.
Where did I say that?
In your slide, actually. It was the top thing in your slide.
Oh, sorry. Yes. No, I actually hadn't started reading this slide yet.
Oh, I beg your pardon.
So there you go. In that particular case, it was depending on the network that they were looking at, I believe is the answer. And I don't want to speak for everybody else's statistics, but from other statistics we've read, it's not always faster because in general, one would expect IPv6 and IPv4 to be, roughly analogous, the same performance is what you would expect.
Indeed.
What I found when I was running a large network was that sometimes it was faster and sometimes it was slower, and if you average them all together, it turned out that it was about 15% faster on average. I think that I didn't include links to everybody else's presentations there, but I think that Facebook, Akamai, LinkedIn, and TWC have all said in public that, yes, they're seeing lower latencies on average, which doesn't mean all the time.
Is that 15% statistically significant?
Yes. Jeff Houston did a report show where he compared his analysis and said, you know, I've got millions of samples, and you know, which is enough to believe it's actually there, and it's I mean, he would phrase it differently. He would say, look, if I do a plot and show how many times V6 is faster and how many times V4 is faster, then it's 5 to 15% of the time V6 is measurably lower latency, but measurable might be 1 to 3 milliseconds. And obviously, anything lower than a milliseconds, generally we're not measuring at internet scale. So there you go. On the other ones here, one of the things that I have found when people actually figure out how hexadecimal works is that actually doing address plans and subnetting, once they get their heads around how hex works, it's simpler, and they say, oh wow, I never have to add 32 to 191 ever again. That's really handy. And then segment routing is a case. Actually, Ron Bonica, who's on the call, did a really nice presentation at NANOG on how segment routing works and how it can be useful. So we're starting to see that as arguable whether it's a simplification, but people who have talked to, who are looking into it or taking it seriously or deploying it, have said, yeah, we really like it because it does, it makes our network simpler. And then we've seen IPv6 addresses used both as process identifiers and as service bits. So TerraStream, that's Deutsche Telekom network architecture, has talked about many times how they're using certain bits in the network address to designate what service, and therefore they can do all kinds of interesting filters and routing based on bits with significance in the network number. Now, there are reasons not to like that, but they're also, they like what they're doing. So I'm just reporting that it exists. At least, it exists in the field, and they're doing interesting things with it. So I promised that that I was going to keep this short because I think that John and Jade have lots of interesting, concrete things to talk about on their networks. But I do want to summarize to say, I think it's important to note that enterprises are lagging in their deployment. I don't think that's an IETF problem. I think that's I think that's a prioritization by enterprise network administrators issue, and I think it will take care of itself, or with help from the operator community. We've been talking for the past several years. Most people think about the V6 transition in terms of getting to dual stack. That's only a halfway point, because dual stack doesn't actually solve any kind of V4 runout problem. Or the other thing I've been talking about recently is it's not just a V4 runout problem. You might also just want to sell your V4 addresses, which, that's also, then you're a revenue problem that you're trying to get to. I will argue that V6 is currently where V4 only, where dual stack was in 2011. Then we had World IPv6 launch and sort of bumped up the dual stack deployment significantly, but it would surprise me not. We will be seeing a lot more V6 only networks or V6 plus translation in the next even just single year, definitely within 2 years. Big question when we talk about V6 only. There's a language vagueness that I keep hearing, which is, does V6 only include some kind of transition mechanism? Some people, when they use the term, it does, and some people, when they use the term, it doesn't. So try to be explicit. I do want to recommend that we encourage an IPv6 only mindset when we're working on stuff at the IETF. This is what we start to see is people assume dual stack. If they think about V6, they assume dual stack, and like the router ID question earlier is, yes, a router ID is a 32-bit integer. Sure does look like an IPv4 address, but it doesn't have to be, and just separating those helps. I did want, so Aaliyah had specifically said, hey, are there gaps that we need to pay attention to? There is in the Sunset 4 working group. There's a gap analysis draft, but it has long since expired because every time somebody mentions a gap, we quickly toss it over to the appropriate working group and work begins on remedying that. So I don't know of any current IETF protocol capability gaps. That doesn't mean there aren't any. There are certainly still some tussles, as Brian Carpenter described in 6-Man recently. that I think is, are still useful tussles for us to be having. And my personal take is that we're going to discover that different networks have different requirements. The other thing I wanted to ask for, even recommend, is there is coming a possibility for IPv6 to work better. We've already seen interesting things that you can do with extension headers and with the number of bits available. But comes the point where IPv4 thinking is going to slow us down, and we need to allow IPv6 to actually outpace IPv4 in terms of benefits. We can't just let the new protocol suffer because not every feature can also be done in IPv4. So I don't even ask for feature parity anymore because we can't always have it. There are things you can do in v6 that you can't do in v4. So,
but that doesn't mean that we should neglect v4, because if we neglect it, it will end up in another SDO declared as national infrastructure.
I think that is a useful conversation to have, but I think that there certainly comes a point where trying to drag v4 along with us as we develop in v6 it becomes impossible.
That's not quite. I mean, there's a subtle difference in terms of what I said and what you answered.
Okay.
Because what we should try not to do is to end up in a world where v4 needs things and we don't supply them. And because my feeling is that if we don't, the ITU will be there declaring it critical national infrastructure, and that will be us out of that game.
So I think there's a point where we start to say, just let it go, Indy. I don't think we're quite there yet, but there is I have a draft in Sunset 4 that tells the IESG to stop chartering IPv4 only work, and is probably going to go to working group last call in the next month or so. So look for it, comment on it in Sunset 4 if you want to. It's a very short draft, like 1 page. And
isn't there an IETF policy that every new feature has to be supported in both v4 and v6?
I don't think that's written anywhere.
Any IESG people?
Yes, there is RC, I think it's 6540, that does say we need to make sure that we're not, we need to ensure parity. But it doesn't say don't charter new v4 only work.
And to say that everything has to be v4 and v6, for example, segment routing is not a capability we can do in v4. Mm-hmm. You can argue that it's in MPLS, but that's actually a different protocol. Mm-hmm. So it's not possible to have parity in that sense.
I don't want to cut off questions, but I have a feeling that people are going to have a lot more than want to talk to John and Zaid about. So, Aaliyah?
Okay. Sure. Thank you very much, Lee. Before I turn it over to John, I noticed that we have a call in user 7. Could you identify yourself so we can tell if you're on the phone?
That's probably me, as Donald Lee's site. So basically, my voice connection and my computer visual connection are not connected together on the display.
Okay, and correct me, that's Don Eastlake, right?
Yes.
Awesome.
Yes.
Thank you very much. Okay. Let me just put that in so we can tell who's speaking when you do, because not all of us have great voice recognition. And then, John, if you're ready, I'm going to turn it over to you as presenter.
Thanks, Aaliyah.
Thank you very much.
You guys can hear me, yes? Can you hear me, Aaliyah?
Yes,
yeah.
Absolutely.
Can you see my slides?
No, not yet. You'll need to start them up again. I do have you as presenter.
Stand by. What do you see, Aaliyah?
We see your slides.
Yep.
Thank you very much.
Perfect. Okay. So wanted to say thanks for everybody to everybody for including us here. I want to do take a quick minute to introduce some folks who are kind of that we're doing this jointly here. So Zaid from LinkedIn is also on the phone with us. Zaid and I have been doing a lot of work together over the past few years. I'll let Zaid, make a few comments here in a minute. And then I have Chris Luke from Comcast. He's a colleague of mine who's actually led a lot of the work that we're going to talk about here today from a Comcast point of view. Chris and Zaid, I don't know if you guys like to make some comments to kind of kick things off.
Yeah, sure. Hi, I'm Zaid from LinkedIn. As John was saying, we've been working together for the past few years. So LinkedIn, I've been sort of leading the effort on getting us to v6 on the edge, which we've been doing for a number of years. And that's not sort of as significant, in my opinion, as what we're doing inside the data center now. Sometime mid-next year, we will run out of RFC 1918 to support our internal data centers, including internal cloud applications that we're building with like containers and things like that. We've already started the groundwork on v6 only data center. And then as we are sort of like hitting the work in that area, we're finding lots of interesting things, a lot of major gaps that we would like to help get resolved so that we can sort of move things a lot faster. We're finding that over time we will have a lot of technical debt, if I were to summarize that, and that supporting dual stack is just it's not an option for us from an operational perspective. So we already are thinking about moving there, and as we are getting there, we're finding a lot of challenges, which is why I helped write this draft to get to v6 only and what things we should be thinking about. That John will sort of go into a little bit more depth, and I'll chime in. So I'll leave it at that as a summary.
Chris, Luke, any comments?
Sure, I'll keep it very brief. I've spent several last years recently here focused on improving how we automate, how we get our engineers to be part of that automation, improving the success of that as it hits the network, and how we get those things to work over v6 in general, and a bunch of work more recently on how we get things like third-party clouds connected to our network in a secure way, again, over v6.
Thanks, Zaid. Thanks, Chris. So if you guys don't mind, we'll kind of get started here with our regularly scheduled program. So a little bit of background for you guys. This is not, we share this, we find that sharing kind of the current state of deployment of Comcast from a v6 point of view helps people understand truly what the motivation is for us, right? Over the years, and I look at the participant list here, a lot of familiar names, a lot of familiar voices. So many of you, have probably heard some of this at some point in time in the past, 5, 6, maybe even 10 years, right? But it is important for us to kind of use this as a cornerstone to help you understand why we're doing the things that we're doing and why these are not simply science experiments that, that are not going to go anywhere. These are things that we need to run our business, right? Approximately 10 to 12 years ago, we had deployed v6 initially. So the first 5 years of my time at Comcast were basically helping to get the infrastructure ready, starting in 2005, so that we can launch v6 for something that none of you would ever see, right? Which is basically the management of a cable modem using IPv6 only. Today, if you look at that green bar, and my little chat window here is in my way, that is the number of cable modems that were added to the Comcast network that would not have happened without v6. So back in 2000 and maybe 12, 11, something like this, we had begun our full-scale migration of modems to v6 only for management, no v4, right? This is something that we've done, that we did kind of largely with our vendor community, touch of involvement from the IETF, but largely done with cable labs. Back then, we had about 20 million cable modems on the network. Today, we have over 44 million cable modems on the network, and only about about 400,000 of them remain in v4, mainly because they are either customer-owned or the vendor doesn't exist anymore to provide us with firmware. Important point, that this alone is probably one of the world's, it is a very large v6 deployment on its own, just for modems. So our broadband deployment, Lee alluded to this earlier. Today, according to, and pardon the kind of the micro imaging here, I snagged this from Jeff Houston's APNX stats page this morning. According to Jeff, as of June 6th, we have 70%, I believe, capable. And I think his data is stuck for the past few days. So once he unsticks it and the graphs refresh, you'll see that this will continue to go up. But what you'll also find, as that was alluded to earlier, that's not really what the true measure of the V6 penetration is within the Comcast network. And this is an important point for us to highlight. Even though the rest of the world either sees some average that equates to 54%, or Jeff sees 70%, we've deployed V6 to 90% of our customer base as of today, and that continues to increase. And that is dual stack. So we have not done anything from a V4 point of view as far as broadband is concerned, but we'll talk about that here in a few slides. Broadband point of view, X1 point of view, which is probably what we will anchor, at least from our point of view. Aaliyah, do you still see my slides?
No, I just lost them. Can you represent them?
Yeah, I lost Sharon. Are they back?
Back now.
Okie dokie. So X1 is our basically next generation video platform. And as of June 1st of last year, we had migrated half of the devices in the network to be V6 only, no V4. Beginning of this year, you see the up and to the right graphs. We had completed the rest of that to the tune of tens of millions of set-top boxes into V6 only mode, no V4. One of the things that you should take note of is kind of the velocity of that migration, number one, and number two, the relevance of it being V6 only. Video systems within cable networks have gone far beyond closed systems, right? If you look at X1, we have a YouTube application that will be forthcoming. We have Netflix today. All these things you'll find in the news, right? You can listen to Pandora. You can listen to, you can like thumbs up things with Facebook, right? So this is more than just a closed video system. It's a lot more interactive today than it has been in the past. So for many of you, for any of you who have suffered through kind of legacy video systems, this is not that. So without that being said, and I believe our current percentage today is probably greater than 95%. It's probably something to the tune of 98%. We have a handful of, we have one bug that's affecting a very small population of these devices that we'll finish up here. But either way, I think you guys get the point. The message here is the vast majority of what we're doing here at Comcast is V6 only, right? So since 2005, a lot of what we've kind of set out to do is to really minimize that dependency on V4. I'm sure Zaid will echo that comment as part of his work at LinkedIn. And today, I think it's fair to say that easily 65, 70, 75, maybe 80% of our business runs on V6. Our internet traffic has grown to be about 40%. We're working hard to kind of gather some statistics, hopefully to share at a future session like this, or perhaps during the IETF this summer. And really, one of the things that you'll see here in the back 9 of these slides is our springboarding of the V6 to for all intents and purposes tactical uses as a platform for innovation, right? So a lot of these things you could say we migrated modems to V6 because V4 simply wasn't big enough, right? X1 V4 wasn't big enough, right? So now we have this interesting platform that we are kind of desiring to innovate on top of. Any questions, comments?
John, I had a question on your slide on the set-top box. You had 3 lines. One was V4 only. What's the red line?
So the red line, that is a fantastic question. So the blue line, so every set-top box today is like a video gateway, right? It is a video delivery device in and of itself, but it is also a router for video content, right? So think of it as a home router, but for video. And we don't have a one-for-one, right? So some customers choose to only have one set-top box in their house, while others choose to have more than one video device in their house. So for cases where people have more than one, we have kind of like like a master-slave model where one of them will be like, you know, the brain in the house, and the others are satellite nodes within the home. So it's effectively, you know, kind of an island home network dedicated to video. So the two lines basically are our telemetry and metrics around numbers for deployment of each type of box, right? So obviously the blue line are video-only devices, whereas the red line are devices that would be video-only plus gateway support. So
cool.
Said differently, the blue line only gets a /128 through DHCP-v6. The red line gets DHCP-v6 plus prefix delegation.
Cool.
Clear?
Yep.
Cool.
Thanks.
You got it. Been here, did that. Any other questions, comments before we kind of springboard into the back nine here?
Hey John, this is AC. You said video routing. Are you doing anything with using the v6 address for caching of the video content?
Not yet.
Okay.
But AC, one thing to note here, you know, you and I have kind of crossed paths in various areas, perhaps HomeNet, for example. One of the things that's probably important for us to kind of highlight here, and this is something that Lee and I spoke about in, I guess, with Chicago, right? And it wasn't specific to the routing area, but it was specific to, it was kind of more generic to IETF proper. You know, we had to proceed with our kind of design for that video home network, not using anything that came from the IETF. It wasn't going to be done in time, so we had to move on.
Okay, yeah, that sounds like an interesting presentation in and of itself.
Happy to field some questions later, and if you want to, if you want to have a discussion about that, we could do that. But honestly, AC, I mean, I'm not interested in a food fight or a knife fight in Prague, right? So we're happy to share that perspective, but there's no turning back at this point, right? We're done, right? Meaning we've finished the migration. So
I was going to say that at DT we've had some issues trying to find v6 video solutions. So that's one of the problems that we had. Yeah, we'd be happy to talk to you about what we've done. And your name from DT? Christian Hops.
Yeah, Christian. Myself and I think maybe even Chris and even the gentleman that we work for. We have some pretty we have some interactions with DT and the TerraStream with Axel and other folks. So we'd be happy to follow up with you on that one.
Sure, no problem. Or I talk to my own guys.
They might not know enough about what we've done. So if you're interested, feel free to reach out. Happy to talk to you.
Okay, thanks.
So springboarding here to the back nine, right? Kind of moving off some of the background here. So a lot of this sets the stage for what we intend to do moving forward, right? v6 only networks, because now you ask yourself, why do you need v4, right? If most of your traffic and all your services are running over v6, then what do you need v4 for? And frankly, and Chris and Zaid will probably comment on this as well. It kind of gets in the way, right? It is still an occurrence on occasion, and Chris will keep me honest, at least from a Comcast point of view, where we'll do a maintenance on a dual stack portion of the network that happens to be a v4 only maintenance. That's generally not a good thing, right? So there's a lot of things that we're looking to try to do to help simplify, optimize, and make the network, better, right? You'll see a lot of kind of sound bites here, v6 only in the cloud, because again, if all of our services that we use the cloud for, whether it's internal or third party, are v6 only, then why do I need v4, right? And then of course you have things like v4 as a service, and then other Comcast services like Xfinity Home and Voice, that all have a path and a trajectory for IPv6 support. Questions, comments?
Well, any customer incentives to move to v6 only, and how relevant would that be for you in the home market?
So, I think that the day and time for trying to incentivize something that, I'll answer the question this way, right? Most regular internet users don't know how v4 works, right? So it's tough to incentivize people with v6 when you'd have to basically teach them what does v4 work, mean, and then by the way, here's v6, right? So after this, and I'm happy to have a conversation about this, but in the long run, the goal here is to basically, be able to kind of make changes from an internet protocol point of view without anybody actually even noticing or caring, right? So, incentivization is, it's a fine line, right? We can have some interesting discussions about that. Happy to do some of that here, or even in the next IETF. But truth be told, I talk to a lot of my customers, right? Believe it or not, like real customers who I don't even know. Many of you are my customers who I do know, and I talk to you as well, right? But most of the people, outside of this phone call, who are my customers, don't really know how V4 works, right? So it's a tough sell from an incentivization point of view.
Yeah, so I have an offer. In TerraStream, you're going to be tunneled, right? It's not going to be as fast as IPv6, so that's one incentive.
Yep. But that was Christian, right?
Yeah, sorry, I had some background noise.
No, that's okay. My voice to name recognition kind of sucks. But I agree with you. But Christian, the interesting thing there is, as V4 traffic tapers off, in a strange way, it'll be tunneled, like for V4 as a service. And I think you guys are using lightweight 4/6, if I'm not mistaken. And as traffic tapers off, right? Yeah, my assertion basically has been people might not even notice, right? Because it'll be lesser load on the border routers and other stuff like that. People, as they kind of trend more and more towards the V6 only experience, they might not even know, right? And frankly, I don't think we want them to know, because we don't want them to kind of notice enough to have to call us, right?
Yeah.
So my other part of the question was in terms of how relevant is it to you, right? You were mentioning IPv4 only maintenance operation, and so I was wondering to what extent you have an opinion about the cost incurred with the V4 or V6 in the home for your support team. Yeah,
but Tarlis, I can't. I have more control over what I do in my network. If I took 192.168, 0/24 away from your house, there'd be like a revolt or a coup or something, right? It would basically be pretty disastrous, right? So years ago, many years ago, I thought to myself, hey, I wonder if there's a day where we'll have I kind of glimmered into the future towards a day that was a V6 only experience, right? And strangely enough, we're like on the cusp of it, right? And then I said to myself, hey, like I wonder if there'll be a day where we can actually turn V6 off everywhere. So lately, I've kind of come to the realization that we'll probably be able to turn off V6 in parts of IP networks, right? The home is probably going to be one of the last to go, right? And I may or may not be around to see that, whether retired or alive, right?
I think there was a Freudian slip in there. I think you meant turn off V4.
Perhaps. I think you all know what I meant, so no problem, right? So turn off V4. That's right. So like but for V6 only, I mean, in the home, it's probably going to be one of the last places to do it, right?
Okay, thanks.
Yep.
Well, there's certainly going to be there's certainly a lot of V4 only gadgets that will be there forever. For example, my television knows V4, and it will have a long and hopefully productive life.
That's exactly one of the devices that comes to mind to me as well, right? So, to kind of get back to our regularly scheduled program here. So one of the things that Chris and I have been working on is, again, leveraging this notion of V6 only infrastructure to basically develop what we call Clover internally. It's basically short for cloud overlay, where instead of running dedicated infrastructure like fiber and routers to leverage third-party clouds or even remote internal clouds, we basically use IPv6 as a bit of an extension cord to create what we call virtual data centers, all built on V6. Again, for the underlay, with the intention of being able to support, obviously, V6 only overlay traffic or dual stack traffic. So I don't know, Chris, if you want to make any comments about Clover or any additions here.
No, I mean, Clover is a fairly simple thing. Most of the work in it is orchestrating the tunnels at both ends. It's not too dissimilar from SD-WAN conceptually. The twist here is that while they're heavily focused on using what those vendors consider the internet, which is predominantly v4 based, our initial target is a v6 only based internet. I don't think there's anything to write home there.
Yep. One of the other things, Chris, and keep me honest here, is you know, we're obviously looking at you know, commodity hardware, you know, running Linux, and a lot of the work that we've done as of late kind of revolves around, you know, FDIO and the VPP contributions to that project for performance, right?
Yeah, so there's a couple of things that are interesting with VPP. It uses DBDK, which most people know, but it also uses the hardware accelerated crypto stuff that many Intel chips have alongside it, which means that, you know, hypothetically, it could get many gigs of IPsec performance out of it. I've not benchmarked that myself yet, but I've seen some promising numbers that give many commercial platforms a run for their money. So that would be the back end that we host on our network, and in effect, what we're doing is accepting that there will be a tax for the crypto overhead for landing that tunnel on a VM somewhere in some third-party cloud.
Questions, comments?
So I'm not sure whether you're the right person to ask, but there was an IETF document that was published recently that sort of said that we need to do segment routing over v6 because we can't do v4, can't do MPLS everywhere. I'd like to understand to what extent we're missing the things that stop us running IPv6 everywhere in terms of the infrastructure.
Do you really mean just v6 or v6 only?
Yeah, if I want to run v6 only, all right, as a control plane for other services, what have we still not built?
Yep. So I've yammered in your ear for the better part of 30 minutes now. Chris, Zaid, I'm certain you probably have thoughts here.
Not particular to segment routing. I know that maybe Russ is a better, if he has written. Which doc are you referring to, by the way? Are you referring to
the use case justification for v6SR? So I'm trying to find out. If there is a general problem with us not having the protocols we need in order to be able to run everything with a v6 control plane.
Right. So if I can interrupt 1 second, so Stuart, your question, which is why I asked to edit it, right? If your ask is what is kind of preventing us from v6 only infrastructure, right? Then I think that Chris, myself, Zaid could probably have a few comments there for you, right? But if your question is specific to SR and v6 on top of v6 only infrastructure, then
I want to know what is missing. What are the set of protocol? What things have we not designed, updated, or modified so that the infrastructure could turn off v4?
Well, I think for one, like we don't have things that could start from scratch on v6, right? I think it's always configure v4 first or set up things on v4 first, then get things on v6. Possibly, like maybe some idea on intent would be good. So generally, when we set up networks inside data centers, and in fact, we tend to make it human touch, less on human touch, right? So programmatically, we want to do things, and unless you have the v6 from ground up, it's not generally easy. You end up having tech dev or people configuring things on v4, forgetting to do things on v6. So I think that the whole general thing is that it's not set up from like boot time on v6, right? And so if you think of it from that perspective, then all the protocols that you either support or you rewrite should do v6 only.
I think what I'm hearing is that there are certain features that can be built on top of v6 that cannot be built on top of v4. Not that we need some extension in OSPF or ISIS or pick your favorite routing protocol. Yeah, do I hear that correctly? Or are you saying that there are some extensions in OSPF, ISIS, BGP that we need?
Ron, you know, if I can jump in, and Zaid will keep me honest, and Stuart for you as well. So like today, like there's at least there's a use case that I'm looking at directly right now. It's our new building, right? For example, our new building is going to be V6 only, right? No V4. And we basically said, to Zaid's point, right? The enterprise network engineers have to go ahead and build this network without V4, right? Every device that comes out of the packaging from the manufacturer will not turn on V6 by default. It will not, and if it does turn on V6 default, it doesn't do it in a uniform way that basically allows for a consistent experience for kind of the everyday engineer to go ahead and turn up a brand new network with V6 only, right? The same concept applies to what Zaid was talking about in data center networks, as well as our regional networks and many other scenarios for us as well, right? So there's a mix, right? And if I take a poll on the call around this call, and I say, okay, everybody raise your hand who implemented a feature for their company or in a product that a company like Comcast would use, and then I say, okay, and it was a dual stack, it was a V4 and a V6 feature. I ask questions like, which one did you do first, right? Is V6 on by default, right? I would ask a series of questions because we already know the answer, right? We see the process by which people go and implement things, and frankly, have their maybe in some cases specified, because when we go and try to deploy this infrastructure, they basically come out of the packaging, V4 only, with requiring V4 to turn it on, no V6 by default. And then we can start the rest of the conversation that Stuart asked, right? Like, what happens? Like, is there, how can a router configure itself? How can it kind of automatically enable interfaces? Build adjacencies and blah blah blah, right? So like the question, Stuart, might not be, is there work that has been missing, is there work that's incomplete, or more importantly, is there work that's simply missing, right?
John's question.
Jumping to
Are these products that Comcast has purchased, or that Comcast customers have purchased?
Comcast has purchased. In the two cases that
the RFP or the RFI? Can't you put a line in there that says anything you sell us has to come with V6 on and V4 off?
Yes, but I can add some color to that. We have one optical transport vendor who does both DHCP4 and Slack, but they have a nice little quirk that the first one wins, and the other one doesn't get attempted. It's just an example of an inconsistent behavior.
We would just send that back, but I mean, you guys, obviously you have a more functional network than we do, but to Fred's point, we require V6 working, that wouldn't be working in our RFQ.
So far, most of these questions have been...
Stuart, before you say something, I don't think your question was answered. I think in the context of routing working group chairs, I think that we're fairly done. I mean, not done, but I don't think we have a lot of gaps. And to John's point, I think that at least where we see all the gaps are in the implementations, right? So, for example, Pixie, IPv6 over Pixie exists, right? But when I try to use it, I'm looking around at scavenging to find some solution that actually works, right? That's been implemented. It's an outlier, and a lot of it, that's what I think John was saying, is that everything seems to default to V4. Everyone delivers V4, and then maybe V6 is there. But as a protocol standpoint, I don't know if we have any gaps, at least not with the main stuff in routing.
Yeah, and Christian, if I can jump in there, I mean, like, we might not, we may kind of respectfully, disagree a little bit, right? We think there's some areas for kind of interesting work to kind of make things better, because if you look at Pixie, for example. I think the people who, and I wasn't around when Pixie V4 was done, so like, when I look at Pixie, but when I compare the two, Pixie V6 was basically a copy and paste of Pixie V4, right? It just with V6, right? So there's an opportunity here with V6, right, as you've heard in multiple times in this conversation, to do things differently, right? If we continue to copy and paste V4 and make V6 do a V4, then we're stuck with, a V6 version of IPv4, right? To Chris's point about Slack, Slack doesn't really usefully exist off of a local link in V4, right? You require DHCP, relay agents, stateful databases, and look, guys, I'm a huge deployer of DHCP, right? So I'm not poo-pooing DHCP. I don't do that, right? I use the right tool for the right job, but at the same time, internally within the company, and I'm sure, again, Chris and Zaid will agree, with V6, we design for V6 first, and then we will only pull back and implement the stuff we have to for that kind of looks like V4 for backwards compatibility, right? But the other way around, it seems to be what's happening the most as far as implementations, and even in some cases specifications, right?
John, I think that's a great point. So Stuart asked if there was anything keeping us from running a V6 only network. So I think to that, I don't think there is anything specifically, but to your point, we can do a lot better, right? If we're not just copying and pasting V4 work.
That's right.
Yeah, I think some of the problem lies at the doorstep of the V6 Ops working group. And at the risk of jumping to a solution, maybe a good thing to do would be to bring ideas into V6 Ops, like I want to do foo on the V6 network. I want to do zero-touch provisioning. I want to do whatever. We work that through in V6 Ops and figure out what pieces are missing. And then, with the hammer of an RFC, we either get the vendor's attention. It may well be that the problem is that V6 isn't enabled by default on any vendors, and that needs to be a requirement. Or maybe it's a requirement off to the ISIS working group that they need a new TLV to do whatever. But probably the right way to start is to look at what projects we want to do over V6 that we never even thought of over V4. Describe them and generate requirements for other people, either vendors or other working groups.
So Ron, I'll challenge you a little bit, right? So, like, I don't have 5 years to wait for an RFC, right? And, like, hopefully I have not offended anybody, right? But I think everybody would agree that it takes a lengthy period of time. We have to strike a balance between the documentation aspects of this, i.e., 3 to 5 years it takes to get an RFC, and actually running implementations. Chris, myself, and I'm sure Zaid as well, again, could kind of tell you that, like, a lot of what we've done, we've done, by rolling up our sleeves, working with, implementers, writing our own code in many cases, to kind of prove out many of these concepts sooner rather than later, so that when we come to the IETF or other SDOs and we propose something that we think makes sense to be standardized, we already vetted it out. We know it works, right? And we've kind of found some of the bugs and enhancements that we didn't want to wait, 5+ years to find, right? So I think, the one message that I'll send here is, like, we have to strike a balance between that, the process that we know today and the process that we need moving forward.
So if I can just
agree with that, John. The one comment I'll make is that the best balance might be to follow both paths.
So if I can chime in a second, two pieces. One is, it's fine to say we don't have vast gaps, but when was the last time in routing where a new feature came in the first version we did or talked about was for V6, where that was the piece that got done? And I'm thinking about, the IGPs, for instance, where we get lots of TLVs, and yet the TLVs and the first version of work that comes in is always doing it for V4. And by the way, here, we have a V6 encapsulation or format because we have to, but that doesn't get the emphasis. And so I think one of the things that we could do, or that those who are interested in V6 could do, is encourage, and V6 only, of course, is encourage thinking about the first version being the V6 encap or formulation, and then how do we get to V4? The second thing I'll say on time, and I don't want to spend a lot of time on this, but 90% of my job as AD is encouraging people to move faster. We do have some existence proofs. Things can go faster, but it does take time and effort, and coming in with pieces that work or pieces that are starting, that are being actively implemented and played with for the experience can make it go much faster. I think, John Scudder can give some perspective on some of the speeding up of work that has happened in IDR for certain topics that are hot. And, this is a forcing function that operators and others can perform in the IETF to say, no, we really need this now. The expectation of slowness is part of what causes us to be slow.
Can I ask a question here? Are you talking about draft, individual 00 needs to have V6 in, because every draft will have to have a V6 solution before it gets to the ISG?
Right. What I'm saying is, what if the first version of something new was for V6, as opposed to, oh yes, we're going to have to do that, and we throw it in later? Because people will go off and experiment with the first version, right? They say, oh, is there interest or demand? And they think about it in that context. So then what we do is we, as John was saying, it's the V4ification of V6, as opposed to the other direction, which is, let's start with it being V6 and move from there. I mean, where I'm one of the prototypes. Hold on a second, sir. One of the places that I'm thinking about, for instance, is OSPF, where there's OSPF v3 and there's the LSA extensions, which has a huge amount of functionality there. And, that work ended up stalling because there just weren't any implementations of it. And so all of this various new functionality that's being added in theoretically is there, theoretically is documented, but it's so much paper.
So, Aaliyah, we can go back to the mid 2000s. We did the Monet stuff, and we did it on OSPF v3, and it was limited commercial deployments, or even in defense, even in government deployments. It was my company had an implementation of it, but we kept it in a different branch even. So it was it's not that we haven't tried. It is. We're just getting a different message from the market.
Right.
And I think our scope is the protocols we design. What goes on in product land is nothing to do with the IETF in terms of prioritization.
It just lags. I disagree with that. It just lags by. So you almost have to package it and sell it to the products.
We're not. Yeah. I mean, what we're doing. Sorry, let's continue on and let John finish. But the IETF doesn't exist in a vacuum. It's very much tied into what's being done commercially and equally to the point what's actually being implemented. So.
Hey, John, can I make a comment here on the original one? This is Zaid. So earlier someone had asked, what is one of the gaps, right? So in our document 5.7, right, we're basically saying, for example, I'll give a simple example. For instance, IPv4 address sort of should not be required to determine about ID, right, for any protocol. Like that is, I think, fundamentally missing, right? So if you ask, what's missing, so I'd point to that, RFC 6540, that kind of stuff, right? Any sort of control plane implementation must support recommendations of RFC 744, these kind of things, right? Using local link address only. So I think there are fundamental gaps, right? I don't think we have time to go over them on this call, but there are. I don't want it to be just sort of thrown out that there isn't.
Thanks, Zig. Aaliyah, quick question, time check. We have until 12:30, yeah?
We have until 12:30, and what we'll see is, if it runs a little bit long, some folks will be able to stay in some long. But
okay.
Yes.
All right, so I'll kind of step it up a little bit then, if that's okay. The slide that you see now on the WebEx is a little bit of a background slide. So basically, all of this is just telling you, hey, we have a legacy network, and the goal here is for us to cap and grow, and to build and really kind of build and add our capacity to the next gen network, right? So the next few slides here are going to be where we kind of get into some topics around kind of some of the next gen stuff, right? So this slide here, without belaboring too much, is a slide that originally had names of executives in here from our company. But for now, that's been anonymized, but basically the ask from our executive team, basically falls into these sort of things, right? And you can imagine, kind of the further down the bullet points, the higher up in the food chain, right? So, our most senior leadership wants us to change the business, right? Driving down a click or two, we want to make sure that we make better decisions using better data. And then, of course, at a kind of a more technical level, we have things like improving the experience for the customer, improving how we run, automate, and operate the network, reduce downtime, improve our ability to kind of react to situations. One of the things that's probably important to note here, which will kind of we'll use as a springboard into some additional material here, is we want to reduce the blast radius, right? For as long as I've been here, we have been a deployer and buyer of large routers. So a large router blows up, the impact radius is pretty big, right? So those large routers take longer to build, longer to test, longer to deploy, longer to harden, et cetera, right? So one of the things that we're looking at, you'll see here in the next few slides, is what it is that we're trying to do to kind of make segments of the network powered by smaller, higher volumes of smaller routers, so that we can manage the blast radius. This picture here, Chris, I don't know if you want to kind of comment on the slide that's up on the screen now, but this is kind of a capacity depiction of how the existing network would be augmented by kind of the new deployment.
Kind of the idea is to take some of the concepts of spine leaf and turn it sideways, where the two sites are both effectively spines talking to each other as though each other was a leaf, so that we can start adding capacity augments as a kind of an N1 plus model. There are some prerequisites for that. Fixed place plate port density is a key factor to the scaling limits of this particular model without introducing extra boxes for this sort of coplanar thing. So we have this running as a trial at the moment between Ashburn and Atlanta, which we hope to have the first trial semi-production traffic running in August.
Thanks, Chris. Let's see here. Okay, so going back to limiting the blast radius, changing the kind of the profile of what we're looking for within, from a physical device point of view. We're not looking for refrigerator style routers anymore. We're looking for routers that are almost look and smell like servers that you'd see in a data center, right? And Zaid, I don't know if this kind of resonates, how much this resonates with you, but we're looking to kind of trend more towards commodity, less towards specialized. Picture on the left, actual, picture on the right, logical, with the idea that we integrate kind of layer 3 and the optical layer as well into this concept where we can zero touch everything, right? And the zero touch comment will be something that we use to springboard into the next few slides.
Yeah, we don't have any calls generally in our data centers, and going forward, like most web scale data centers are completely callless and a typical 5-stage class with one queue as the simplicity design.
Thanks, Ed. All right, so some things here that that I think will start to kind of be a little bit more universal, probably maybe viewed as outside the scope of the routing area, maybe even the scope of the IETF, but based on Aaliyah's request, we want to share some of this information with you, right? So today, the way that we run the network, we log into a box, probably over before, somebody cut and paste, and Zaid's probably not going to agree with this because he's probably better at this than we are, right? And Chris is probably mad at me because I'm not giving us enough credit, but I think the truth is somewhere in between, where today we log into a router, over before, cut and paste the config into a terminal window, and then log into another router, and then another router, and then another router. And probably somewhere in there's an expensive lab in a facility somewhere that we'll try to run those configs through and do our best to kind of keep all that stuff up to date, right? So one of the things that we're looking to do here, that becomes increasingly difficult when you have a wide range of vendor implementations, diverse syntax, everything from stanza-based to, kind of line-based, what have you. So one of the things that we're looking to do is to basically fully automate all that, right? Change the paradigm around how we kind of generate, store, and push configs to routers, right? In some cases, we're even talking about, again, fully automated. Chris can elaborate a lot more on that than I can, and I'm sure, we learn a lot from Zaid as well. But the idea here is that there's no human who touches a router, and the human who touches the router, in our case, basically, broke the router. And I know, at least through one conversation I had, we said internally, if anybody logs into the router, we RMA it and send it back to the manufacturer and get a new one, right? Because it's considered broken at that point, right? So everything, and this topic alone really kind of orbits around several key points, right? Everything from concepts like zero-touch provisioning for the initial provisioning of a device, as well as zero-touch for ongoing maintenance of the device, right? What does that look like? This conversation internally for us has often led us down, and I'll say a rat hole with the hopes that maybe, I don't know how Chris or Zaid will react, but basically the rat hole for us has been, when you talk about zero-touch, we start talking about, Yang models or not Yang models, netconf versus something else, or OpenConfig. And from our point of view, we would just be happy, I think, if a lot of that just worked even using a native configuration for the device itself. So I'll pause there, see if there's any questions, comments, or criticisms, and then we'll see if there's a wider discussion to be had here. None. So one other side note about this particular component, and I'll proceed to the next slide, is one of the reasons that we're looking to go ahead and do this is really to not only automate kind of deployment and operations of the production network, but we want to also be able to model and simulate that in a virtual environment, almost in a pre-staging capacity, so that when we have what we believe is a candidate running config, or a new candidate running config for a router that is being updated or a router that is brand new, we want to be able to kind of spin that up, automate the creation of it, automate the testing of it, all so that we can use that as a bit of a staging process before it goes into kind of a pre-launch state. So one of the other concepts here, and this is tightly coupled with this notion of ZTP, right? And then we'll talk a little bit about ZTP here more in a few minutes. But the idea here is that at any point in time, if Comcast wanted to rebuild a router on the network, every one of a class of routers, a region of diverse routers, I think every single one of you are familiar with /configure or make all, make whatever, right? The idea for us is that we could be able to, we'd be able to do that in kind of, software kind of vernacular. We could, make PA New Jersey, make all CMTSs in PA New Jersey, and rebuild all those configurations as well as deploy them, without any human intervention. Questions, comments? Okay, so I think we're getting towards the tail end here. Let me just advance a little bit. Yeah, getting towards the tail end here, and we have a few more minutes. Perfect. So network Jenkins is one of the things that we often talk about internally. I won't belabor this any further, but like if you look at some of the screenshots here, we happen to be using Git and Git stats for some of the stuff that we're using internally. And we basically populate, basically build trees, and we start to treat the network configurations like software for now, right? Seems pretty basic, no rocket science there, but really it's where we go from here using some of those fundamentals around, some more software tools to basically, further automate what we do with some of those ingredients as far as the network is concerned. One of the key components here for this one is some of the stuff that we mentioned here throughout the day, or at least the session for Zero Touch. So going back to the conversation we had a few minutes ago about, I think it was Stuart's question about, like, what are the gaps or what are we missing? One of the things that we find, and again, I'm sure Chris can comment on this, is, if we want to do zero touch over v6 today, that it feels like the only way to possibly do that is through PXE over v6, which, isn't entirely interoperable and doesn't always work, right? I think Chris is say again.
Yeah, I can give some color to the process that we've got in our trial backbone sites at the moment. The iPXE that's on the boxes will do v4 and v6, and it DHCPs both and waits until both gets an address and has some kind of timeout. And it will prefer v6 for then fetching things, but it's entirely at the behest of whatever DHCP returns in terms of a URL to go fetch things from. So the way we have that configured is that the v4 DHCP config has a v4 literal in the address, and the v6 one has a v6 literal in the address to always force it to use the one that was configured. The complication is with once the system is booted up, getting the initial config on the thing requires some kind of ZTP process on it to work, which varies from vendor to vendor. And in one vendor's case, has had all kinds of issues with either working with v6 only, either because it just doesn't see the RAs or something like that, or in some cases, in the v4 case, decided inside the box to use overlapping 1918 space that our web server for their configs happened to also exist on, so it couldn't reach them. So neither protocol worked on that particular example.
So I guess question for you guys, Aaliyah, Stuart, like where, in your view, where would something like that fall into, what realm would that fall into? Is that an IETF problem, an interop problem, a routing area problem, not our problem at all, Comcast problem?
The PXE boot or the network, Jenkins?
PXE boot. Using Chris's example, right, where he, we had this problem where, PXE boot, on one hand, I'm sure we would say, as IETF proper, PXE has been specified in RFC, right? But the reality situation is it doesn't work, right? Or it's fragile at a bare minimum, right? So what do we say about that? Like what's our reaction? Is that we don't know what we're doing?
Was just saying that it might not even be PXE boot, but it might be vendor-specific second-stage bootstraps there, right?
Yeah, there's no standard for ZTP at all. It's entirely by convention that you might have a URL in one field in DHCP, but once the system is booted, you get that URL, you go fetch something from it, and it might be a config, or it might be a shell script, or it might be something else.
Look, we have IETF offerings, existing and upcoming for zero-touch secure boots, right? So in Netconf and Anima, so I think it's a question whether, for different type of devices, there is, any incentive to move to them as opposed to sticking with this PXE boot, which I think primarily is on the x86 side, right?
It's not at that step of things. You'd have to. PXE boot is totally untrusted, but it's also totally on the local LAN usually, except that I think you're doing something more complicated. To me, it sounds like the overlapping addresses sounds like a routing problem. We should have told people not to do NAT. We should have told people not to use NAT and just use v6, obviously, because then you wouldn't have this problem, right? So that sounds like a bug of having ever tried to use v4 at all. It doesn't work. But I didn't understand, why did the v6 not work?
It was an implementation issue in that specific case.
Oh, okay. So there was no the v4 overlapping v4. No one can fix that with code, but the v6 is okay. Got it.
But to the larger question, and that's the kind of thing which might be or I could see at least looking at it from a BCP. Or to take a look at the particular protocol pieces and say, is this operating advice or implementation advice that we want to provide, so sort of the best common practice to make it work well, or do we actually need protocol changes there? I'm afraid I'm not familiar with this with PXE myself, but that's my initial reaction.
The PXE by itself is probably not the problem, other than there's no clear defined interaction between v4 and v6 and when to fall back to v4 if v6 doesn't work, for example. In general, though, my experience with ZTP isn't so much that any individual protocol is at fault, but stitching them all together has a lot of variation in how it's done. So maybe BCP is the way to solve that problem.
Chris, also, you know, if you're running an NFV on a server versus a router, you know, the bring-ups are all different and there's issues, right?
Yeah, but also to add clarification, in this particular deployment, all of my network devices are also PXE booting. They have an x86 chip on them. That is their root processor. It is envisaged that the primary mechanism for upgrading the image on these machines will be to wipe it and reboot it.
That doesn't sound like a terrible thing. It just seems to me like that, you know, going forward, you should think, can I do this with v6 link local addresses rather than routable v4 private IPs?
The complication there is that these are all remote sites for us, and they may not have a local resource available. At the moment, the configuration we have is a DHCP helper on an upstream management device and a dedicated management network.
Yeah, I think you should look at Anima. I think Torlis is right, and comment on whether this is helpful to you, because I think this is within the realm of.
But
yeah,
the other part that's interesting is if one of the challenges, you know, what I heard is that one of the challenges you're seeing is not the individual protocol pieces not being specified, but the system chunks and how to make it all work together. And it seems like that's the kind of thing where BCPs or understanding and looking at what the issues are for the interactions, you know, may end up with protocol changes. It might end up with BCPs, but at least if we hear about the consistent problems, we could solve them in a reasonable way. Anyway, I know we're running out of time, so I would like you to continue.
Yep. So Aaliyah, real quick. So you know, as you know, I've recently gone through this. We also don't have a common singular definition of BCP, by the way. I've learned that the hard way recently. So I don't disagree with that as a possible path forward, but at some point we're going to have to we're going to have to figure out what the common definition of BCP is, and how that kind of is a uniform definition within the IETF. Because today I learned through a different body of work that I did in V6 Ops that there is no single definition of that. Anyway,
can I ask a question about this network Jenkins in terms of what's the relevance of IETF work in this one, right? So in between this running state, intended state. So I'm wondering.
Yeah, the Jenkins part itself, honestly, is probably more of something of interest casually, but really how what it means to how networks run is, and how they're going to be run, is probably the most relevant aspect of this, right? So I mean, a lot of what we've tried to do over the years is to kind of shed light into the standards communities, whether it's IETF here or Cable Labs or what have you, as to how networks are really kind of built, deployed, and run, because they often have pretty significant implications as far as the work that gets done in the respective bodies, right? So Jenkins is more of just conversation starter, kind of give you an idea of one way that we're looking to solve this, but what it truly enacts is really what we are intending to be the focal point here. We want to expose people to how we're planning on running networks, with the hopes that if there are considerations in the standards process that need to be factored in, that people do that, right?
Yeah, and that's what I was asking, right? In terms of if you've been tracking the work on the Yang models and kind of how the relationship between the operational model and the configuration model to enable that type of orchestration system you're building, right? That was the the focus. Yep.
And who was that?
Torlis.
Hey, Torlis. So I have a question for you. So I've kind of been waiting for this question to come up today, right? So of all the implementers on the phone today, who implement something that gets deployed in a production network, does anybody implement your feature using the Yang model first? Using Yang first? Anyone?
I'm working on that for one of the.
I don't understand the question.
Yes.
So when if somebody from Cisco or Juniper or whoever's on the phone, right? When somebody's writing code, right? And maybe I'll kind of pick on Ron because I know Ron pretty well, and he won't get that mad at me, right? But when Ron's writing code at Juniper, right, and he's getting ready to write a feature that's both v4 or v6 or dual stack or whatever, when he writes the code, right, and he has to write into the configuration database that will eventually produce show config commands or show configuration, right? Does Ron write that with Yang first? Does Ron write it with the native Juniper config and then add support for Yang later? Does Ron even add Yang support to a future release because he ran out of time, right?
The answer is yes and no. As for the IETF standardized Yang model, I believe that no one on the planet has ever written an IETF standardized Yang model first and then written the feature. However, if you take a look at the interface between RPD and MGD, the two modules, the configuration and the running modules, that interface is a precursor of Yang and has been since 1998. So in some sense, people write something like Yang first, but IETF standardized Yang, no. And as far as I know, that stands for that goes for every implementer on the planet.
And you could ask Kent Watson, perhaps he's also Juniper, he may have a similar response, I think. But
so John, let me answer this one as well. This is Benoit with Cisco. So yeah, we make a distinction between the new features, for which it's easier, right, as opposed to an old one like BGP, which has been there for years. And for one of these new features, typically segment routing, we're trying to do Yang first. And I try to push do Yang first before the CLI. And then from the Yang, you can do the CLI and not start with the CLI first. Now, as Ron mentioned, I wish the standard bodies would be way faster to develop those Yang models, but practically, you develop the feature first with a private Yang model, and then you go to a standard.
Yeah. So Benoit, I mean, I was kind of hoping that you were out there because this question was for you, my friend. So like the. Yeah, and as much as we wouldn't object to that, right? Whether it's open config or Yang models or what have you, but the painful truth is, right? Even though I know in your heart of hearts, you pushed for Yang first and CLI second, I think we all recognize that they come out with the native configuration first, right? So long story short, I'm almost forgetting how we got here, but there's a bit of a disconnect, right? Operationally, right? So if we have a feature that's a native config, but no Yang support, and then but there's a Yang model, we have a problem, right? So there's a matrix of complicated situations that exist there that I think we all need to kind of come to terms with and figure out what to do about, right? Because the question that was asked of me, I think how we got here is, why does Git matter? Git really doesn't matter specifically. What it represents, kind of infrastructure as software, matters more, and how that fuels how we run networks moving forward, right? I think that's really the main point here. So I have 2 minutes left, probably not enough to kind of give it's correct. It's kind of due, points here. Having things like telemetry and measurements and all those things kind of operating uniformly over V6, everything from OpenBMP, BGPLS, or even things like IPv6 and NetFlow, right? They're all pretty important. I think going back to the Stuart's point earlier, probably not many. Maybe there are some gaps there. Nothing comes kind of racing to mind right off the top of my head. Perhaps, Aaliyah, we can kind of dive into some of this, at a later date. But I want to leave at least, a minute or two for Chris and Zaid to kind of make any closing comments and to see if there's anything that you want to talk about before we all part ways. Chris, Zaid, anything you wish to add before we move on?
No, nothing more, man. I think we covered it all.
Yeah, something specific. Just the work we've been doing on our Backbone project to work through this whole ecosystem of a feedback-driven mechanism. It's stitching together a lot of things that are quite in ascent and promising, but it's also frustrating that some of the older stuff that we thought worked didn't work as well as we thought it did. But I think that we'll get there over time.
Leah, back to you. Oh, sorry. Go ahead, please.
No, this is Benoit speaking. If I could just add one thing, because whenever you mention native, right, native config, I was actually speaking about native Yang models to start with. And then we go to the standard. Now, there is one thing that I would like to speak to you and to describe. This is what we're doing with this Yang catalog, in which we're trying to load all the models we know of, the one coming from IETF and OpenConfig and native ones, right? And trying to look at what is implemented. And coming back to your network linkings, this is one step going from data model first to see what's available, specifically for your service composition. So we might want to follow up on this one.
Great. I appreciate that. Well, thank you. Aaliyah, back to you.
Okay. Thank you very much, John. So one point I'd like to pick up from the Jenkins discussion and tying back to the Yang models is we've got a lot of models coming out of routing for basic features, but we keep adding features. And so one of the things I think that you're pointing out and which would be useful to emphasize is we need to have a plan for as we go forward with new functionality being standardized to make sure that the Yang models don't lag behind and that the necessary augmentations or extensions for the Yang models come at the same time as the feature so that this type of network management is possible. Is that a good summation?
I think it's good enough for now, right? So.
Okay, cool. So thank you very much. I really appreciate all of you coming. We've had a lot of lively discussion, and please, happy to continue more on the mailing list, and let me know if there's some interest in asking John or others to come to the lunch or some other time when we can have some more discussion. Thank you very much. I'm going to end the recording now.